Hello, and welcome to Astronomy Daily. I'm Anna.
And I'm Avery. It is Monday, March 23rd, 2026, and we are back for another week of space and astronomy news.
And what a way to kick off the week, because right now, as you're listening to this, a rocket is sitting on a launch pad in Norway waiting to make history. We'll have all the details in just a moment.
We also have the story of a cosmic explosion so powerful it would dwarf 1 billion suns that nobody saw coming. We've got a docking drama unfolding at the International Space Station and a pair of so-called failed stars that are, rather brilliantly, refusing to fail.
Plus, we're going to take a little trip back in time, 60 years, to one of NASA's most heart-stopping emergencies and the extraordinary photos that have only just come to light.
6 stories, 0 filler, let's go.
All right, story 1. And we want to say right up front, this one is live, as in the launch window for this mission opened just a few hours before many of you are listening to us right now.
That's right. Today, Monday the 23rd of March 2026, Germany's ESA Aerospace is attempting the second flight of its Spectrum rocket from Andøya Spaceport in northern Norway. And this is not just another rocket launch. This is potentially a landmark moment for European spaceflight.
For context, until very recently, no orbital rocket had ever launched from the European continent. None. If you were a European company or agency that wanted to put something in orbit, you had to go elsewhere. That changed just under a year ago when Spectrum flew for the first time, but that first flight ended roughly 30 seconds after liftoff when a vent valve issue caused a loss of attitude control and the rocket came down into the sea.
So today's flight, titled Onward and Upward, is the comeback. It's ESA's qualification mission, and it's the first time Spectrum will carry actual customer payloads. We're talking 5 CubeSats from European universities and companies, including teams from TU Berlin, the University of Maribor, and the Technical University of Vienna, all flying through ESA's Boost program.
And the stakes are real. ESA's European Launcher Challenge requires participating companies to reach orbit no later than 2027. If Spectrum succeeds today, ESA takes a massive step toward proving European commercial launch is a genuine independent capability.
The launch window opened at 9 p.m. Central European Time, that's 8 UTC, and ESA CEO Daniel Metzler has described this flight as, quote, a deliberate step toward delivering sovereign access to space for Europe and allied nations.
So fingers crossed, everyone. We will absolutely be covering the outcome tomorrow. Spectrum, fly straight and fly far.
Story 2, and we're going back 60 years because sometimes the most remarkable stories are the ones history almost forgot.
Most people know Neil Armstrong as the first human to walk on the moon. But before Apollo 11, before the Sea of Tranquility, there was a moment in March 1966, 60 years this month, when Armstrong came extraordinarily close to not surviving a mission at all.
Armstrong was commander of Gemini 8 alongside pilot David Scott. The mission successfully docked with an unmanned Agena target vehicle, the first ever docking of 2 spacecraft in orbit, a critical milestone for the Apollo program. But shortly after docking, the joint spacecraft began to roll uncontrollably.
Armstrong undocked from the Agena, thinking it was the source of the problem, but that actually made things worse. The Gemini capsule went into a violent spin, reaching 1 revolution per second. The crew were on the verge of losing consciousness.
Armstrong managed to regain control using the re-entry attitude thrusters. But using those meant the mission had to be aborted immediately. Gemini 8 came down in a secondary recovery zone in the Pacific, where Armstrong and Scott were retrieved by the USS Mason after several rough hours at sea.
And now, 60 years on, never-before-seen photographs of Armstrong's return, his rescue from the Pacific, his arrival, the relief on the faces of those around him, have been donated to the Armstrong Air and Space Museum in Wapakoneta, Ohio, the museum that bears his name.
These aren't widely known images. They capture a moment of pure human relief, the calm after one of NASA's closest calls in the pre-Apollo era. And they serve as a beautiful reminder that the path to the moon was paved with moments of extraordinary courage under pressure.
We'll link to more on this story in the show notes. If you're a space history fan, this one is well worth a read.
Story 3, and this one genuinely blew our minds when we came across it. It involves an explosion so powerful it released the equivalent of the total radio energy output of billions of suns. And astronomers completely missed it until they found the echo.
So let's set the scene. Gamma ray bursts are the most energetic explosions in the known universe. They happen when massive stars collapse and form black holes, firing jets of high energy radiation into space. Within seconds, they release more energy than our sun will produce over its entire 10 billion year lifetime.
The catch is those jets are incredibly narrow. We only detect gamma ray bursts when the jet happens to be pointing directly at Earth. If it's aimed elsewhere, the initial flash goes completely unseen. These are sometimes called orphan afterglows, and they've been theorized for decades, but almost never caught.
Until now, using the Australian Square Kilometre Array Pathfinder, ASCAP, based in Western Australia, astronomers detected a radio signal designated ASCAP J005512-255834. It brightened rapidly over a period of weeks, then began a slow, steady fade, and it's still detectable more than 1,000 days later.
Left almost no trace at visible light or X-ray wavelengths, which is exactly what you'd expect from a jet that wasn't pointed at us. The researchers, led by Ashna Gulati and Tara Murphy from the University of Sydney, described this as the most convincing orphan afterglow candidate ever identified.
There is one other explanation, and it's arguably just as wild. The signal could be the echo of a star being torn apart by an intermediate mass black hole, a category of black hole that sits between the stellar mass black holes born in supernova explosions and supermassive monsters at the centers of galaxies. Extraordinarily rare, extraordinarily hard to detect.
Either way, the discovery opens a new window on some of the universe's most extreme events. The team hopes to use the same approach to find many more of these hidden explosions, cosmic blasts that never announced themselves with a flash, but lingered quietly as ghosts in the radio sky.
Ghosts in the radio sky. I love that. The paper is published in the Astrophysical Journal, and it's well worth reading.
Story 4, and this one's genuinely alarming. The global astronomy community is raising the alarm over 2 proposed satellite projects that experts say could fundamentally and permanently alter humanity's view of the night sky.
The first is SpaceX. In January this year, SpaceX applied to the U.S. Federal Communications Commission, the FCC, for approval to launch up to 1 million satellites as orbiting data centers designed to power artificial intelligence systems from space. 1 million.
To put that in perspective, right now, there are approximately 14,000 active satellites in Earth orbit. SpaceX is proposing to increase that by a factor of over 70. And according to astronomers, even a fraction of that constellation would add thousands of naked eye visible objects to the night sky at any given moment, in some cases outnumbering the stars themselves.
The second proposal comes from a startup called Reflect Orbital. They want to launch up to 50,000 mirrors into low Earth orbit, each one about 55 meters wide, designed to reflect sunlight back to Earth to power ground-based solar installations. Each reflected beam, astronomers warn, would be around 4 times brighter than a full moon. And it wouldn't stay in one place.
Robert Massey, the Deputy Executive Director of the British Royal Astronomical Society, described the situation as, quote, really intolerable, saying it would be, quote, absolutely the destruction of a central part of human heritage.
The Royal Astronomical Society, the European Southern Observatory, and the International Astronomical Union have all filed formal objections to the FCC. The ESO estimates that SpaceX's proposed constellation alone could contaminate up to 10% of data from the Very Large Telescope in Chile, and potentially up to 30% for certain kinds of observations.
The concern is compounded by the FCC's approach to evaluating these applications, fast-tracking them without requiring environmental impact assessments. and the public comment period has already closed.
This is a story we'll be watching very closely. The night sky has been a shared human heritage for as long as our species has existed. The idea that it could be fundamentally transformed, not by a natural event, but by commercial interests, is something the astronomical community feels very strongly about. And honestly, so do we.
Story 5, and the quick heads up, this one is also an evolving situation. The docking is scheduled for tomorrow morning.
Yesterday, Sunday, March 22nd, Russia's Progress 94 cargo spacecraft launched from the Baikonur Cosmodrome in Kazakhstan on a Soyuz rocket. It's carrying about 3 tons of supplies to the International Space Station: food, fuel, scientific equipment, and medical supplies for the Expedition 74 crew.
The launch itself went smoothly, but shortly after separating from the rocket, engineers noticed a problem. One of Progress 94's 2 Curse automated rendezvous antennas, the system the spacecraft uses to home in on the ISS for docking, failed to deploy as planned.
Troubleshooting is ongoing, and all other systems are reported to be working normally. The spacecraft is continuing its 2-day journey to the station regardless. Docking at the Poisk module is scheduled tomorrow morning, Tuesday, March 24th, at around 9:30 Eastern Time.
If the antennas still can't be deployed by then, Expedition 74 Commander Sergei Kutsverchkov will take manual control, piloting the spacecraft to dock using the telerobotically operated rendezvous system, essentially a backup control panel located in the Zvezda service module.
Manual docking of a cargo spacecraft is not something that happens every day. It's a demanding procedure, but it's been done before. Commander Kutsverchkov is an experienced cosmonaut, and the situation is being monitored carefully.
We'll have an update on how this one resolved in tomorrow's episode. For now, fingers crossed for a smooth arrival.
And finally, Story 6, and this is our favorite one of the day. It involves brown dwarfs, sometimes called failed stars, and a discovery that even the researchers themselves struggled to believe.
Brown dwarfs occupy a strange middle ground between planets and stars. They're more massive than gas giants like Jupiter, but not quite massive enough to ignite and sustain the nuclear fusion that powers a proper star. They glow a little, mainly from deuterium fusion in their earlier years, but they fade over time, hence the nickname failed stars.
Now, binary systems, where 2 objects orbit each other, are common in the cosmos. And we've long known that in certain binary systems, mass can transfer from one object to another. A white dwarf stealing matter from a companion, for instance, can eventually trigger a supernova. But this kind of mass transfer had never been observed between 2 brown dwarfs. Until now.
A team at Caltech, led by graduate student Samuel Whitebook, was searching through data from the Ziggy Transient Facility, a sky survey telescope, when they noticed something unusual. An object designated ZTF J1239 plus 8347 was changing dramatically in brightness roughly every 57 minutes.
What they'd found was a pair of brown dwarfs orbiting each other at astonishing proximity. The entire system, both objects, would fit within the distance between the Earth and the Moon. They're spinning around each other once every 57 minutes. And one is actively stealing mass from the other through what the researchers describe as a kind of gravitational nozzle, creating a hotspot that blazes in blue and ultraviolet light.
Co-author Thomas Prince put it simply, "These are very exotic objects. We've told some of our colleagues about them, and they didn't believe such a thing exists."
The system is about 1,000 light years away in the constellation Ursa Major, close enough to make it an excellent candidate for follow-up observations with the James Webb Space Telescope. And as for what happens next, well, there are 2 possibilities. Either the thieving brown dwarf gains enough mass to ignite fusion and become a real star, or the 2 eventually spiral together and merge into one brighter object. Either way, as Whitebook puts it, the failed stars get a second chance.
The paper is published in the Astrophysical Journal Letters, and it's a genuinely wonderful read.
And that is your Astronomy Daily for Monday, March 23rd. 6 stories, 1 live launch to watch, and 1 pair of brown dwarfs proving that even failed stars deserve a second act.
Tomorrow we'll have the outcome of the Spectrum launch and the Progress 94 docking, so we might be bringing you 2 cliffhanger resolutions at once. Subscribe so you don't miss it.
You can find us wherever you get your podcasts and across all our socials at Astro Daily Pod. That's Twitter/X, Instagram, TikTok, YouTube, Facebook, and Tumblr. And our full show notes and source links are always at astronomydaily.io.
Until tomorrow, keep looking up.
And keep wondering. Goodbye, everyone.
Astronomy.